So right here we've got, I can draw and describe the reflection of a figure across a line of reflection. So we're going to be talking about reflections today. So this should be kind of easy for us. So our vocabulary word is rigid motion. So when we get there, we'll talk about what rigid motion is. So it says, the illustration shows irregular pentagon-shaped tiles covering a floor.
What chapter is this?
Chapter 3, or topic 3. That's what they call them in the book. So they want to know, well, which tiles are copies of tile 1? And to explain. It's like all the blue tiles, right? All the blue tiles are a copy of tile 1. But now, does the tile right beside it, does this look exactly like tile 1?
Yes.
I mean,
No.
so this one's not, see, look right here, this part's a little different. It looks like, but maybe it's not, maybe it's the same.
One has like the one that's connected, that piece is kind of flat. Wait, so, no, it's not the same.
It's hard to tell.
It kind of actually looks, it looks really close.
Okay, so how could we tell for sure if it was the same? If we could move tile 1 and put it on top of the other tiles.
You can like fold it like that.
Yeah. Right? So what you're describing, moving tile 1, that's called rigid motion. Where we move something but it maintains its shape, its integrity. It's not something that when we move it, it loses its form. So it says, if you were to move tile 1 from the design, what actions would you have to do so it completely covers tile 2? So think about it. If I wanted to cover up tile 2, what would I have to do to cover it up?
It looks like you'd have to flip over 1 to cover it, because 2 looks like the same thing. So you have to cut.
Okay, so 2 does look the same. But how could I make, so what did you say to do? To make 1 cover up 2? Flip it over, right? And then imagine that flip. That is what we're going to do as a reflection. Okay? So the light tiles here are not copies of tile 1, but they are mirror images of tile 1. Which means if I reflect it over, I should get that original picture. It's just in a different color. So here we're talking about rigid motion is a transformation that preserves length and angle measure. So is the transformation a rigid motion? And explain. So this is the terminology they use. Pre-image. That means this is your original structure. This is your original image. And then after some transformation has occurred, the new one is called the image. Okay, so when I look, we want to know, is this transformation rigid? So did we preserve the length? So are all the lengths the same? So look down here at this bottom length. Right here to here, are they the same length? No. So did we preserve length? No, we didn't. So this here is not rigid motion. The angles look like they're the same, right? All the angles look the same, but the image is smaller than the pre-image. So we changed the length. This transformation is not rigid because length is not preserved. Remember, if we change the actual shape, if it does not keep its original form, then it is not rigid motion. Okay, so this is telling me I've got a drawing here, and I want to reflect it over this blue dotted line. So, in your head, can you imagine what it would look like if you reflected this over that line?
Yeah.
Like what's going to happen? Well, it's basically like this image is going to
gonna be the other way, the F gonna be pointing to the rock.
Right, it's gonna like flip over the line, right? Imagine folding this over. So let's draw a reflection here.
It's gonna look like upside down spider knives.
So like if H is the distance from here to here, then I'm going to preserve that distance. Right, so like right here, this would be my new point. And so what we label this is H prime. All that means is this is H after the reflection has occurred. Right, H prime. Alright, F looks like it's this distance. So I need to maintain that same distance here. So right here would be F prime. And then G goes from there to there. So from here to here, this would be G prime. And so we're going to talk a little bit more in depth about how to reflect these. And I didn't do a great job because I didn't measure out, right? I just kind of eyeballed it. I just kind of guessed the lengths. But I can say a reflection takes on this general form, right? How I've reflected it over that line. My F maybe should be a little bit more here, right? Just looking at what I've done. But just a general form, that's how we reflect it. So the next one we're going to do reflection on a coordinate plane. Okay, so this tells me quadrilateral FGHJ has those given coordinates. So we're going to graph that on our graph paper. That's the first thing we need to do. Okay, so draw you an X and Y axis on your graph paper, right? So you got it labeled. Something like this. And that tells me F is at 0, 3. So that means I'm here at the origin. 0 means I go left or right nowhere. 3 means I'm going to go up 3 to here. So right here is 0, 3. And I'm going to label this point F. Okay. G is at 2, 4. So I'm going to go right 2. I'm going to go up to 4 right here. So that would be my point G. It tells me H is at 4, 2. So I'm going to go right 4, up 2. That puts me here. This is my point H. And it tells me J is at negative 2, 0. So I'm going to go to negative 2. 0 means I stay here. So here's my point, negative 2, 0. And that is labeled J. And now then I just connect them to form my quadrilateral. Right, so quadrilateral means it's got 4 sides. And right there's my shape with 4 sides. Again, if you need straight edge rulers, I've got them somewhere.
It kind of looks like a Pac-Man.
Anybody want straight edge? I know I've got rulers somewhere else. Right here. Wonderful. Okay. Now, I've got my original graph and labeled. Any questions about this? Now next, it tells me to, alright, here's the notation. Capital R, right here the subscript says x-axis, and then this is the thing that we're going to reflect. So what this means is, it wants me to draw a reflection, capital R, reflection across the x-axis of my figure. So what I'm going to do is I'm going to, again, we had the line drawn before. That was the line we were going to reflect over. This time the line they want me to reflect it over is the x-axis, which is here. So let's think, how could we reflect these points across the x-axis?
Steph, have to turn all of the y's negative.
Yeah, pretty much, right? So like G here, you see how G was 4 units away from 2? So now I can go 4 units away here, and that is where my new point G should go. So I'm going to label that point G prime because it's the reflection. And now I'm going to do the same thing with my other 3 points. So F was here. F is 3 units away from the x-axis. So I'm going to go another 3 units here to -3. And this is going to be my point F prime. H is 2 units away. So I go another 2 units away from the x-axis. And so this point is going to be H prime. And then what about J?
It's gonna stay the same.
J is on the thing that I'm wanting to reflect. So it stays on that same line. And so right here, this would be my point J prime. And if we connect them, what we can see is we took the blue line and we reflected it. We essentially flipped it over the x-axis. Okay, then Grayson said something interesting. Okay, so what happened here when we reflected this over the x-axis?
Like Pac-Man.
Okay, it does it like a Pac-Man. But like, think about these points. The point H used to be at 4, 2. Now, what are the coordinates of H prime? Nope.
Negative
4,
negative 2.
-2. So H prime is at 4, -2. Okay, look at G. G used to have coordinates of 2, 4. Now, what is G prime's coordinates? 2, -4. So what is happening after I've reflected it over the x-axis?
The y's changed.
All I did was change the sign of my y. So it says, what's a general rule for reflecting over the x-axis? Okay, so when we reflect over the x-axis, we change the signs of our y value. Everything else stayed exactly the same. Look at this one. This one was at 0, 3. Now it's at 0, -3. This one was at -2, 0. What happens when you change the sign of 0? It's still 0, right? So that one didn't change. So anytime we reflect over the x-axis, we're just going to change the sign of our y value. We're going to take that same figure, and now we want to reflect it over the y-axis. So the last time we reflected over the x-axis. So what happened when we reflected over the x-axis? We changed the signs of the y values. So what do we think is going to happen when we reflect it over the y-axis?
It's gonna, the one that's touching the y-axis will stay there.
The y-axis will stay the same, but what's going to happen to all the other points?
They're gonna change.
Change the sign of what? When we reflect it over the x-axis, what did I just write down? We reflect over the x-axis, what did we do?
Change the sign of the Y.
Change the signs of the y. So now we're fixing to reflect it over the y-axis. So what do we think is going to happen?
Change the X.
Change the sign of our x values. Think about it. If you reflect it over the y-axis, a point that used to be at 2, 1 is now going to be at negative 2, 1. Right? So it's just kind of doing the exact opposite. So let's draw our figure out. So I've got 0, 3 here. This is F. 2, 4. This is G. 4, 2 is H. And negative 2, 0 is J. Okay, so I connect them all. Now let's think about reflecting over the y-axis. So let's look at point F. So you already said, what happens to a point that's on the y-axis? It's going to stay there, right? I can't reflect it over the y-axis because it's right where it's supposed to be. So this time F has the exact same coordinates as F prime. So right here is the points for F prime. Let's look at G. G used to be at 2, 4. If I reflect that over the y-axis, what are the new coordinates going to be?
Negative 2, 4.
Negative 2, 4. Absolutely. So right here, this point would be G prime. Okay, look at H. H used to be at 4, 2. Now it's going to be at negative 4, 2. So this is H prime. And then J used to be at negative 2, 0. So it's going to get reflected this direction to positive 2, 0. So this is my point J prime. So now if I connect my 4 coordinates,
Looks like a butterfly.
kind of, but you see how I took the red one and I basically flipped it over the y-axis. I reflected it. I think about, turning a sign around from one direction to the other. Over the x-axis, you can think about the same thing, right? Flipping a sign. But I normally think about literally reflecting. But whenever the thing I'm reflecting is already on the y-axis, you think about like spinning it around, rotating it, reflecting it. All right, so let's make sure we've got it graphed correctly. Has everybody finished graphing their first one? The original?
I've got the original.
Okay. So I want to make sure that we know how to graph them. So let's see, I've got negative 5, 6. That means I'm going to go left 5, up 6, right? So here is my point A. B is at 1, negative 2. So I'm going to go right 1, down 2, which is here. So here, this is my point B. And then C is at negative 3, negative 4. It's going to put me here. So if you've messed up on that part, then you need to go back and review. Make sure you remember how to graph. You can go to Khan Academy. There's all kinds of just help me graph. If you don't know how to put those points down, That's a 6th grade, right? That's where we learned how to graph points for the first time. So you should be pretty familiar with that by now.
Well, I had them all right besides point A.
Where'd you have it at?
I didn't go up, I went to the bottom.
Oh, you went -5, -6?
Yeah.
I got you. So you just
So
maybe copied down wrong.
On B, we fine. Now we go. Now we do no on part. B part.
Okay, yeah. Well, I'm doing A part right now. I haven't done A yet. This is the original.
Oh, we gotta flip it up.
Now then, I have to reflect this over the x-axis.
Oh,
So if I'm reflecting over the x-axis, that means I'm reflecting it over this line. Right? So this time my triangle is on that line. So I'm imagining like if I rotate it. Right? If I were to spin that yellow, like, I'm imagining I've got something on a rod and I'm spinning it. And I'm watching it reflect and rotate over. So my point A used to be up here at -5, 6. So when it rotates over, it's going to be down here at -5, -6. So right here, this is my point A prime. B used to be at 1, -2. Now it's going to be at 1, +2. Which is here. This is B prime. And then C used to be at -3, -4. So now when I reflect that, that's going to be at -3, +4. And so now I've done the reflection. So it wants to know what are the new coordinates for A prime, B prime, and C prime. Okay, A prime, the coordinates would be at -5, -6. B prime, the coordinates would be at 1, 2. And C prime, the coordinates are at -3, +4. So what happened to my coordinates? When I reflected over the x-axis, I changed the signs of all of my y's. Right, which is what we said was going to happen. Now, let's do B part, but let's do it without graphing. So what's going to happen here? If I reflect over the y-axis, I'm going to change the sign of... I'm going to change the signs of my x's. So that means for this reflection, A prime would now be at 5, 6. B prime is going to be at -1, -2. And C prime would be at 3, -4. So again, when I reflect over the y-axis, I'm changing the signs of my x's. When I reflect over the x-axis, I'm changing the signs of my y's. Okay, so the last question, so we're still talking about reflections, which is part of rigid motion. So yesterday we were given a pre-image and we were given a line of reflection to reflect it over, and then we had to find the new points. Here you're going to be given the pre-image and you're going to be given the image, which is what has happened after the reflection, and they want to know what is the line that we reflected it over. So yesterday we pretty much reflected over the x-axis and the y-axis, but you can reflect over lines that are sideways, like here. So when we have these kinds of problems, you're not going to have the blue dotted line. It's not going to be there. You're going to have to find the blue dotted line, and we're going to go over the process of how we're going to do that. So you can see I have the coordinates for K, L and M for the pre-image. And then I have the coordinates for the reflection, which is here, 5, -3, 3, 1, and 1, -5. Now, what we learned yesterday is, okay, if I was reflecting over the x-axis, then I would count how far away am I from the x-axis, and then I would go that far down again. If I was reflecting over the y-axis, how far away am I from the y-axis, and then I'll go that far again. Because those axes that I was reflecting over were the midpoint of my two coordinates. Right? So like if K was here and K prime is here, then the midpoint, I did it in the bad spot. If K is here and K prime is here, the midpoint is on the axis of symmetry. It's on the thing that we were reflecting over. So what we're going to do is, we're going to take our coordinates and we're going to find the midpoint. And when we find the midpoint, we know that point is on our line that we are reflecting over. So, here we go. So to find the midpoint of K and K prime, what we do is we add up the x's. So I've got 5 plus -3. And I'm going to divide that by 2. So that's going to give me 2 over 2, which means the x value is 1 of the midpoint. Then we're going to do the same thing for the y values. So I've got 5 plus -3 divided by 2. That's 2 over 2, which again is 1. So the middle of K and K prime is the point 1, 1. Now we have to do that again with another point. So I'm going to do it with L and L prime. So let's find the midpoint. So if I add these up, 1 plus 3, divide by 2. Then I'm going to add the y's up. 3 plus 1, divided by 2. So that gives me 4 over 2 and 4 over 2, which is the ordered pair 2, 2. Alright? We can do it for the third one, but we don't have to. You just have to do it for 2 of them. Okay? Once I have these 2 midpoints, I know the line of reflection has to go through the point 1, 1 and 2, 2. So I can find the equation of my line through those points. So what do I need in order to find the equation of a line? We're going to be using point slope form. So what 2 things do we need to put something in point slope form? We need a point and we need the slope. Do I know a point that's on my line?
Yes.
Yes. I know 2 of them. Do I know the slope of my line?
Yes.
What is it?
1.
It's 1. We can find the slope by looking at our 2 points that we found. Right? We can go up 1, over 1. So we know the slope of the line is 1 over 1, which is just 1. And we know a point on our line. I'm going to pick this point. I'm going to pick 1, 1. You can pick 2, 2. It does not matter. You could even pick the other point that we didn't find, which is down here. Alright? So it does not matter which point you find. You just have to find 1 point that's on our line. Now we're going to plug this in. So I've got y minus y1 equals m times x minus x1. Right, so everything I'm plugging in is a 1 this time. Alright, then we distribute. Y minus 1 equals 1x minus 1. And then I'm going to add 1 to both sides. Which tells me y equals x is the equation of my line. So that's what it asks for. What is the reflection? It's a reflection over the line, y equals x. So my final answer there would look like this. It's a reflection over the line, y equals x. You know, yesterday we had reflection over x-axis, reflection over y-axis. Today we're going to be doing reflections over some more crooked lines. Start on A part by graphing. So you need to draw your X and Y coordinate plane. Okay, so because this one is so spaced out, I need my bigger coordinate plane here. So it's going to take me a minute here to get it set up. Okay. So hopefully we've started graphing here. So I'm going to graph 3, 8. That means at the origin I'm going to go right 3, up 8. I put my point. This is point C. Next, D part, I'm graphing 5, 12. So I'm going right 5, 1, 2, 3, 4, 5, up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Just barely. Okay, this is my point D. And then E is at 4, 6. Okay, so right here, when I connect them, but there's my triangle, my pre-image, what it originally looked like. Any questions so far on what I've done, graphing that one? Okay, now I need to graph the image after the reflection has occurred. So C prime is at -8, -3. So I'm going left 8, 5, 6, 7, 8. I'm going down 3. 1, 2, 3. Okay, so right here is my point C prime. D prime is at -12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. -5. 1, 2, 3, 4, 5. 1, 2, 3. Okay, forget about it. This is D prime. And then E prime is at -6. 1, 2, 3, 4, 5, 6. -4. 1, 2, 3, 4. So this is E prime. Okay? So I can kind of see the reflection, right? But I don't know exactly where it's at. Like, I didn't just reflect over the x-axis. I didn't just reflect over the y-axis. I reflected over some dotted line, right, somewhere through here. And so what we're going to do is we're going to find the equation of that dotted line. Okay, so here is how we do that. This process is not easy, okay? It's going to take you a little bit of time to do it. Is everybody with me to here? Or do I need to wait just a second? Because we're fixing to start doing the hard part. So I've got to find the line that I reflected over. So if you'll remember back to what we were doing yesterday, right? We drew some quadrilateral here, right? And then if I reflected it over the x-axis, then I was counting, right? I said, well, I went 1, 2 to get here, So I've got to go another 1, 2 to put my new point. Right, is the way we did it. And so this point right here, the thing I was reflecting over was in the middle of my 2 points. Right, I was equidistant on both sides. So what I need to do then is I need to find, well, what is the middle of C prime and C? If I can find the middle, then I can kind of know where the line goes through. Alright, so we're going to use the midpoint formula. That gives us the middle of 2 points. Have you guys seen the midpoint formula before? You heard of it before? Maybe. It's you use it a lot in algebra. Okay? So I typically don't like to write it out as a formula, but I know you guys like to see formulas. So I'm going to write it down. The midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. All that we're doing, like, what's the middle of 10 and 20? Yeah, what's the middle of 10 and 20? 15. What's the middle of 0 and 100? 50. And how are you finding that number? Well, you're adding them up and you're dividing by 2. It's an average. Right? That's what we're doing. So the midpoint formula is just an average. Add these 2 x's and divide by 2. Add these 2 y's and divide by 2. It's just finding an average of these values. So what we'll do is we're going to go back. So we're looking at A part. So C used to be at 3/8. So that's going to be my x1 and my y1. C prime is at -8, -3. So this is my x2, y2. I'm going to plug those into the formula and I'm going to find where the middle is. I don't know exactly where it's at. I'm just doing a rough guess now. But the middle should be somewhere in here. Alright, so let's plug into the formula and see what we get. So I get x1, which is 3, plus x2, which is -8, over 2. And then y1 is 8, plus y2, -3, over 2. So that gives me -5 over 2 and 5 over 2, which is -2.5 and 2.5. So I'm trusting you can put all that in your calculator to find it. So the middle of C prime and C is at -2.5, 2.5. So it's somewhere right in here. So I'm going to call this point C sub M. That's letting me know that's the midpoint of C. And that's about where I was drawing it, right? If we look at, well, where's the middle of C prime and C? Okay, right here at C sub N, at the middle. So now, can you draw a line with just 1 point? No. How many points do you need to draw a line? 2. I gotta have 2 points, and I can draw a line through those 2 points. And I can find the line that is what I'm reflecting over. So I need to do the midpoint formula again of pick another point. So I'm going to pick E and E prime this time. It doesn't really matter. You could have picked D and D prime. I'm going to choose E and E prime. Okay, so I'm going to call this my x1, y1. I'm going to call this my x2, y2. And when I plug those into the formula, that's going to give me x1 is 4 plus x2, which is -6 over 2. y1 is 6 plus y2, -4 over 2. So that gives me -2 over 2 and 2 over 2, which means the middle of E is at -1 and 1. So now I'm going to put that point on. Go to -1 and 1. Right here, this is the middle of my E point, so I'm going to call this one E prime. Now because I know 2 points, I can make a line through those points. This might be where you want your straight edge, right? Let's see, my straight edge, they're back. Come here.
You said now, fool.
There's rulers. Right here's the straight edge. I knew there was something.
Boy.
Get whatever you want to draw. Okay, but in order to get the slope, you're going to have to be very precise when you draw these.
No, those ones catch.
You want to get All right. So when I connect those 2 points, here's the line I'm reflecting over.
So it only has to be two of the formulas.
Just 2.
Was that the hard part?
Yeah, we don't know how to.
Oh.
Find in the middle. Find in the middle. I mean, it's not hard. It's just a lot of work.
Yeah, just.
Plug in, find the middle. Plug in, find the middle. Connect them. I now have a line. Now, what is the equation of this line? Because that's what I'm wanting to know. It's asking for the reflection rule. So it's going to be a reflection over, and I'm going to write down what the equation of the line is. So what is the slope of this line? Nope. If I pick 2 points on the line, how can I get from one to the other? I would go down 1 and right 1. So the slope is -1 over 1. Or we could just write it as -1. And then if I'm going to use slope-intercept form, what's the y-intercept of this line? Where does it cross the y-axis? 0. So I know the slope is -1. I know the y-intercept is 0. So I'm going to put that into slope-intercept form. Y equals -1x plus 0, which is y equals -x. So what is our reflection rule? We are reflecting over the line y equals -x. You know how yesterday we had stuff that looked like this? Reflection over x-axis. Reflection over y-axis. Now we're reflecting over a line y equals -x. That is my reflection rule. Okay? Any questions about this process? Okay? So if I'm doing B, I'm going to graph it. Because it is very challenging to do without a graph. So let's see, I've got this here. So on B, if I graph my figures, I've got my x-axis. Oh, I can't go there. I've got to go all the way to -5 and to 7. Can I even fit that on this graph? -5, -4, -3, -2, -1, 0. 1, 2, 3, 4, 5, 6, 7. Yeah, it can. I just need to shade to the side. Here will work. and y's have to go up to 6, down to -4. So same thing, just shade down. Okay, so if I graph this, 7, 6 is F, so I go right 7. 1, 2, 3, 4, 5, 6, 7, up 6. 1, 2, 3, 4, 5, 6. So this is my point F. 1, 2, 3, 4, 5, 6, 7. Okay. Next, 0, -4. 1, 2, 3, 4. It's going to be right here. This is my point G. And H is at -5, 0. So there's my original. And now then my reflection. Sorry, I need to label that last point. That's H. F prime is at -5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that means right here, this is F prime. G prime is at 2, -4, which would be here. This is G prime. And H is at 7, 0. So this would be H prime. So what do I notice about the original and its reflection?
It looks like it flipped over the Y
Yeah.
in the eyeball.
So it kind of looks like it went over the y-axis. I agree.
But it's making me wonder because G's on the Y. And if it flipped,
Huh.
if it flipped over the Y, G
It should be in the same
it would be
place.
in the same place.
Very
So that's
good.
where I'm-
I like that thinking. So
Oh, I see.
what's cool is, like, my F's, they have the same Y value, right? F and F prime. The G's and G prime, they have the same Y value. The H and the H prime, they have the same Y value. So that tells me it's going to be a vertical line. Okay, but if it was this vertical line, then that means it should be the midpoint, right? So if I'm looking for the midpoint,
It'd be 1 over.
it's not quite the y-axis, right? It's between them. Let's see if it follows for all of them. So for H and H prime, there's their midpoint. Right here, G and G prime. Here's their midpoint. So the line that goes through them all is going to be a vertical line, but it's not the y-axis. Does anybody know what the equation of this vertical line is? Y'all remember the equations of any vertical lines? The slope, the slope of the vertical line is undefined. So I can't use point slope form. Because if I plug in, what am I going to plug in? Undefined? Oh no, that doesn't work. So vertical lines have special equations. And it's something you would have learned in algebra. It's not something we've done this year. Okay? So we don't remember. That's okay. That's okay. What can I do? What can I do? What can I do? Let's label all these points that are on my line. So this is just me trying to teach you and think. You don't have to do this normally. But let's see. This point here is at 1, 1, 2, 3, 4, 5, 6. So the midpoint of the F and F prime is 1, 6. The midpoint of H and H prime is at 1, 0. the midpoint of G and G prime is at 1, -1, -2, -3, -4. So what do we notice about all three of those midpoint points?
They're on, X is all one.
So the equation of the line is,
Their X is the same. Or X equals one.
because their x's are always 1 for all values. So vertical lines, which are lines that are straight up and down, their equations are always x equals some number. And that number is the x value that the vertical line occurs on. So like right here, if this was my reflection, this would be the line, 1, 2, 3, this would be x equals -4. Because every point has an x value of -4. Right here, every x has an x value of 1. Okay? So vertical lines are always x equals a number. If you have a horizontal line, which I'm guessing you probably will on your problems, they're always y equals a number. Right? So if I drew a horizontal line here, what would be the equation of this line? Well, the y value there is 1, 2, 3, 4. So right here, y is always 4. So those are your special cases, horizontal lines and vertical lines. You don't have to use point slope form for those. That's why, as soon as I saw B part, I said, well, we're in trouble, because that doesn't fit with what we've done so far. So, yeah. So I guess what I would tell you is I recommend graphing them. Even though I didn't graph A with you guys, I would go ahead and graph it. I just graphed every one of them. I think it's going to be easier.
A was two small triangles very far apart.
A was?
Yes.
But then once you graph the midpoints, it's easier to find the slope too when you get it graphed. You won't have to use this slope formula that I did over there. But that's enough.